Morning, everyone. Welcome to another Learning at Lambert Labs session. And today's presenter is Tom Schafer. So I will hand over to Tom.
Thanks, Aaron. So today I'm going to be giving a talk on generating code using machine learning, which is kind of an idea that's only really been possible in the last sort of year or so, realistically, and may potentially be something that's quite important for us to think about as software developers going forward. Yeah, I'm going to give a quick overview of machine learning and deep learning. I'm guessing a few of you or many of you will have some knowledge of machine learning, but for anyone who doesn't, I'll give a kind of really high level overview. So machine learning, essentially, a machine learning model, all it really is a function that takes some input and returns some output. But the kind of magic happens because it can update itself based on data. And I'll give an example here. So this is a kind of a sort of drawing of a machine or a deep learning model that takes some image like this. It's an image of a 9 or hand drawn 9, and it returns probabilities of whether it's a 0, whether it's a 1, whatever, up to whether it's a 9. And here with this model, the goal would be for it to have a 1 at the 9, say it's definitely a 9, and a 0 everywhere else. But it might be, say, 0.75 and 9 if it thinks maybe this could also be an 8, a 0.2 at the 8. And that's all machine learning really is. It's this sort of function. And the way it updates itself will be there are these sort of, again, this is a really basic machine learning model. You can go, there are kind of a lot more details, but this is kind of, again, a high level overview. So the model is built up of these nodes. And so these are sort of the first nodes that this input encounters. And so this is an image with 784 pixels. And these pixels will each map to one of these input nodes here. And then there are basically a load of functions that take or that kind of carry this input through the layers and end up here. And these functions that again are kind of drawn out here, going from this node to the next, and so on. These have parameters that can be trained based on the data. And so through that process of training, it starts off essentially random. All these parameters are random, but given data like this, where you say this is this is a 9, we expect a 1 here, and loads of data through that training, this updates and eventually becomes quite accurate. And yeah, so that's kind of machine learning using kind of any number of these nodes. Deep learning is a branch of machine learning that uses multiple of these layers, sort of deep layers. So you could have, this only shows 4 layers, you could have a lot more than 4 layers. And again, this is really kind of the most basic type of deep learning model. You can go a lot more kind of intricate. And the transformer, which we'll talk about as well, is a type of deep learning model that uses this concept of attention. And essentially, with an image like this 9, or a hand-drawn character, there are certain parts of the image that we need to pay attention to, and certain parts that we can kind of ignore. And so there's just this concept of attention where we pay attention to the parts of the image that matter, and we can kind of ignore the rest. You can think about the same in if you're doing sort of any sort of analysis of language. In a sentence, there'll be parts of the sentence that you need to pay attention to, and you want to focus on, and part of the sentence that you can kind of ignore. Words like the or you might be able to ignore. So yeah, that's a kind of high level overview of deep learning. And the next kind of prerequisite is this idea of language models. So a language model is a model that predicts the most likely word or sequence of words to follow from a given input sequence. And so there's an example here of when I was typing out this slide in Google Slides. Google Slides has a language model that took my input that was up to here and predicted the most likely words that were going to follow. So yeah, so these sort of language models are quite common, and you can see one here kind of in action. The most accurate language models use deep learning, which we discussed before, and particularly transformers again, which I've kind of briefly went over. And then common applications of these language models are things like language translation, speech recognition, and things we kind of see. Google Slides, Gmail has the same functionality where it predicts what words you're going to type next, and you can just press the right key and it will automatically fill in all those words. And we'll be needing both of those when we discuss this model that I'm going to talk about called GPT-3, which allows you to generate code. That is a type of language model. So I'm going to do a quick demonstration of making a really simple language model that you can train on a laptop. Zoom in a little bit. So this is going to be a language model that I've trained on my laptop. So I've not got a load of expensive GPUs. It's not going to give anything particularly interesting or exciting because there's only so much machine learning kind of training you can do on a laptop. But it gives a kind of idea of how it works. So here I'm just importing some libraries, mainly this library Keras, which is used for machine learning. My input data for this, so again, going back to the kind of definition I gave of machine learning, you take some input data that trains the model and makes it more accurate, is essentially the Django documentation. So you can imagine one use case would be, you might want to build a model that could write a Django application for you. And one place you might start is training it on all of the Django documentation. So I've just used the first page of the documentation because, again, I'm only on a laptop without a GPU. So it's not going to be, it can't handle all that much data. So the kind of first stage is taking this text, which isn't very useful for training, and turning it into something that's basically more readable by this model. I'm not going to go through every step. And also, if for anyone who's not aware, this is a Jupyter notebook. It essentially allows me to, rather than run the whole thing from start to finish, I can just run snippets of it. So I'm taking this input data, which is this text, and I'm transforming it into something more usable. So I'm taking this thing called a tokenizer. It doesn't need, you don't need to know exactly how it works, but it transforms the input data into something more like this. So it's saying, it gives each word a number. So writing is assigned the number 397. Your is assigned the number 8, and so on. That just makes it a lot more readable for the computer, essentially. Here I'm saying I want to take input sequences of 4 words and predict the next word. And so if I examine the sequences here, you can see that there I'm getting 4 words, and the next word, this is our kind of input to our function, and that we want that to be the output. So we want it to be able to take this input and give us that output, which then leads us to this. Here is our kind of X data, our input data, which is the first 4 words of the sequence, and then Y is transformed to look like this. Okay, I don't need to go too much into the details, but essentially zeros everywhere except for a 1 at the word we want. So in this example, writing was given the number 397, I think. So at index 397, or well, 396, I guess there would be a 1 there. But yeah, the 397th position in this array would be a 1. So there we go, we transformed the data, and now we can build our model and train it. I'm not going to train it here because it does take a bit of time, and I don't need to go into specifics here. But this is basically saying we're building a really basic machine learning model, and there I'm fitting it, and you can kind of see that's where I ran it previously, and it fits the data, and you can see the accuracy going up here from pretty low accuracy to relatively accurate. And because this was kind of a quick demonstration, there are a lot of other things I could do, like I should split the data up into training and validation, but I'm just skipping over a lot of the details because we don't really need them. And yeah, so there we go, we've trained the model, and this is where we can see the output. So again, I'm not going to go really into the details, but these are basically a couple of functions that are going to take in, again, going back to the definition, an input string or a sequence of words, and I want, given this sequence of words, what are the next 5 words going to be? And you can imagine an application of this would be, you might want to know, or how do I do this in Django? And so you could write out the start of a sentence, and then you'd expect a good machine learning model to be able to tell you what to do next. And yeah, so again, this isn't going to give great results because it's just been trained on a laptop. But I will run that again and see what it predicts. So I gave the input, if Django is installed, you should, and it returns see the admin's login screen. So I mean, that's a reasonable answer. You probably see the little rocket ship first, but if you go to the admin URL, you'll see that. So fair enough. These are kind of not great. To write your first review or view, begin by, this is kind of a nonsense sentence, but you need models, you need objects. And then this, so that was a Django related question. Now I'm asking it an unrelated Python question that won't be in this data. To concatenate lists in Python, you can. I mean, nowhere in this data is going to tell you how to concatenate lists, but I thought it would be interesting to see, learn more in the time. So again, I've trained this on a laptop. It's not giving anything remotely accurate, but if I had, a couple of GPUs, then I could get much more accurate results. So yes, that's kind of a really quick high-level overview of how you could build a machine learning language model. Just some context, and we'll move on. So GPT-3 is the main model that I'm going to be talking about in this talk, and that stands for Generative Pre-trained Transformer 3. It's a model that's built by this company OpenAI, and it's a deep learning model with around 175 billion parameters. So again, going back to that definition, the parameters are all the basically the tunable variables in that model that I showed that can be tweaked based on the data. To train it once, it costs around $12 million. So again, the training is like I showed here. I was training this, and it takes some time, but obviously it's pretty cheap to do on a laptop. But for this model, because it's so big, $12 million. In terms of the input data, I used just the Django documentation, but this model used the entirety of English Wikipedia for 0.6% of its training data. So that gives you some context about the sheer amount of data that went into this, like a huge amount of data from various sources. Most powerful language model that's been built to date. But there are a number, so it's incredibly powerful, as you'd expect, given all this training data. And we'll go on to some of the applications and show just how powerful it is a bit later. But I should say, there are some concerns for how this model could be used because it is so powerful. Spam and misinformation, you could very easily create that automatically. Phishing attacks again, and also things like automated essay writing. If you've got this sort of model and you're given an essay at university, say, and you can just give it a few ideas to start on, and it'll generate the essay for you, then why would you bother writing the essay out? So for sort of reasons like this, you can't actually access GPT-3 directly. A few select people have been able to access the API, which I will show some examples of what they've done. But yeah, so unfortunately, I've not been able to use it directly because they're only allowing certain people to use it. Start off by just showing an example of generating text. There was this Guardian article that was quite widely shared of GPT-3 basically generating the whole article. So it was given a few words at the start or a few sentences, and it was just kind of left to certain devices to write the rest of the article. And people were really quite impressed about how realistic the article was, given the only piece of information to start with just a few sentences. And I will link this in the source at the end if anyone wants to read the article. But yeah, essentially very realistic. People have commented that human evaluators have difficulty distinguishing from articles written by humans. It's got great skills at conversation, but it can be very difficult to tell it apart in a kind of normal conversation. And again, as I sort of discussed, it was trained on a huge variety of data, so it possesses a pretty deep understanding of almost any topic, which makes it even more powerful. So now we'll get on to the kind of the most interesting part, hopefully, which is for code generation, or most interesting to us as software developers. Now you think there are some benefits to being able to generate code with very little effort, other than basically telling a model generate this bit of code. in the short term, it helps developers save time. There are lots of perhaps basic features that you don't want to necessarily be spending your time on, that can be just time consuming and laborious. And by kind of handing those off to a model like GPT-3, you can tackle more interesting problems. Potentially bug fixes are just, could be just easily handed off if it's just going to be something simple, but time consuming again. So that's kind of benefits for developers, businesses, potentially help them save money, bring products to market faster, and potentially also kind of from an inclusivity standpoint, allowing people from non-traditional sort of disadvantaged backgrounds building software products you might have not have had the education or the university degree that you might traditionally need to be able to build software. So there are some sort of benefits, and I'll give some examples now. So again, most people can't access GPT-3 directly, so I'm just showing a few videos of examples of generating code using this model GPT-3. Here's an example of building a Python machine learning model. So here, all you have to do, you enter the text about the model that you'd like to see or that you'd like to use, classify images into 5 groups, kind of give a few basic details, and in a second it should, there we go, it's generating the code. And again, this might be the kind of, the classic case of just laborious writing out these lines, and it's done it all for you. Next example, data visualization. So that's quite small, I'll make it full screen. I don't know why the quality is so low, but basically the person's typed in there the type of graph they'd like to see based on this data. Well, this is kind of the conversation. I don't know where the data is, but yeah, so a short snippet of what they'd like to see, given some input data, and there we go. We've got a graph in a few seconds. Let's move on to the next thing when it loads. SQL, sorry, it's not going full screen for some reason. Generating SQL queries. You can see here a load of examples that the users put in, but kind of classic query: fetch departments along with total salaries paid for each of them as total department salary. And there we go, got the SQL query. And this is, I guess, the kind of classic case of people across a business might want to query the data. They know how to say it in English, but they might not know how to write the query. And if it's something as basic as this tool could be really useful for developers don't necessarily want to be spending their time writing really simple queries, or maybe even making basic dashboards, whereas this could kind of automate a lot of that. Show a couple more examples. Name of the employee who earns the highest salary. Again, generates it almost immediately. And yeah, there are a few more examples. I think you kind of get the idea. Generating some React front-end code. So here again, you just type in what you'd like to see. You put this as enter to do button that says say to do. And again, I guess this is a classic easy but slightly, or a lot of boilerplate potentially, just for writing this kind of simple component. And again, there we go. So it generates all this code, and here it's showing it in action. Just saving the to-dos, and I think at some point, there we go, kind of scrolling down, just showing it's a relatively simple component, but this has the potential to save a lot of time. I think, yeah, so that's all kind of really useful potentially for both developers and people across the business, but there could be concerns about, are there any negative impacts of this in the long term? I mean, if you think of the work of a junior developer, a lot of it might just be these sort of simple components, sort of basic code that I've shown in these examples. And if that work can all be automated, then maybe there will be no work for junior developers, and either in kind of best case scenario, it just requires junior developers to spend more time being educated, or worst case scenario, potentially it makes it a lot more difficult to become a developer. And also, as an aside, it becomes easy to build malicious software. So traditionally, if you wanted to write a virus, say, you need a good understanding of computer software and programming, and you'd also need time and potentially resources. But if you can generate it automatically, then kind of broadens the availability of, or for people to build this kind of malicious software. So yeah, some potential negative impacts there, as well as the benefits to businesses. And this kind of leads on to the question of, will this replace the work of software engineers entirely at some point? And I'll just quickly show this website called dbuild, which uses GPT-3. It's still kind of in beta, I think, because you have to, yeah, it's not just available to everyone. But this was one of the examples I was giving, where you can just type in some code, or sorry, you can type in a prompt of what code you'd like to see, and it generates the code for you. And so I can see the potential of more websites coming or springing up like this, that are basically allowing you to automatically generate code based on a basic prompt. But again, you wouldn't need any real kind of developer knowledge, just writing a prompt of what you'd like to see. So, and I think it's very easy, you know, traditionally to say, oh, computers will never be able to do the work of humans in a certain regard. But for instance, if you look at chess, you know, in the last sort of 20 years, we've seen kind of people mocking these chess programs, or maybe 30 years, sort of mocking these chess programs, saying they'll never get to grandmaster level. To, you know, there's no question today, if you were going to, you know, have a match between the best machine learning model playing chess against the best kind of grandmaster, human grandmaster, there's no question that the computer would win. And potentially, is it the same for software engineering? I mean, you see again with autonomous cars, they're getting to the point where an autonomous car is safer than a human driver. So will this replace the work of software engineers? I think it'd be naive to think that the current work that software engineers do could never be automated. But that doesn't mean there will be no work for software engineers. For instance, you know, people need to be writing these programs that write the code. This kind of idea of meta programming. So, you know, writing programs that write programs. You know, potentially there is some work there. So yeah, but it's, you know, it's obviously quite a while away. I don't think anyone's going to be losing their job anytime soon, but it's just kind of something that's interesting to think about in the long term. And yeah, that's about it. Does anyone have any questions?
Yeah, thanks, Tom. So I guess I'm just trying to get a bit more of an understanding of, do you know who, you know, so the GPT-3 as a model was developed as open source. It's not available to everyone at the moment.
Yeah, it's not open source and it's not available to everyone. So you can go, so yeah, it's built by this company called OpenAI. I don't think they're a not-profit. I think they're a private company. They're funded by I think Microsoft, and well, I think Microsoft has exclusive rights to GPT-3, but you can be added to a waiting list, and certain people are allowed to access the GPT-3 API. But no one, or as far as I'm aware, has been allowed to kind of interact directly with the model. It's just these examples are just people interacting with the API.
I think I was just on the OpenAI website off screen, and at first glance, I assumed it was open source because it was called.
Yeah, potentially, yeah, a bit misleading. I think they do open source work, but not GPT-3, which again is probably because of the potential negative implications until we've kind of worked those out.
So presumably they might open it up as an API, but at the cost expense one day, right?
Yeah, I mean, yeah, I think it would make sense at some point. But again, even just with the API, those kind of malicious use cases could sort of come to fruition. So I think there are a lot of unanswered questions before it becomes open to the public. But it would be nice if we all could have a play around with it, because it is clearly very useful.
Thanks.
I got a quick question, Tom, actually. And this is kind of a bit vague, but to what extent can we trust code generated from machine learning?
Yeah, I think that's
generated, I suppose, in like, you know, not in a malicious way, but like,
yeah,
like with all good purposes.
Yeah, sure. I mean, I think that's a very good question. So, for instance, in, you know, these examples, I mean, I guess if you just asked it to, you know, build you a React component, then you would probably just do a traditional sort of code review. But so I guess in that case, it still saves you a lot of time. It doesn't mean there's no work, because you would ask it to generate the code, you would review the code, and you can make any changes or ask the model to make any changes. So I guess in that way, it would just be kind of traditional sort of software engineering practices, but eliminating that writing the code, and you would just have to review it. Because I think you raise a good point. It's not necessarily going to be perfect first time. I guess it's like with anything, your kind of English description or human word description of what you'd like can be quite vague. So potentially you would need to go back, ask it to make changes and so on. So yeah, and I think that's something you need to be aware of, that you couldn't just trust it to work first time. Potentially some tweaking needed.
Thanks, Tom. Does anyone else have any questions? Okay, well, thanks again, Tom. That was a really eye-opening presentation.
Yeah, thank you, everyone.
Thank you, Tom. Cheers.
Great.
Thanks,
Thanks
Tom.
very much.